Hi, everyone. My name is Riccardo Freschi. I'm a solution architect at AWS, which means that basically I help customers and partners adopt the cloud for their solutions. So together with my colleagues, what we do is generally we help these customers and partners, and we produce also reference architectures for them to refer to. So when they have problems or when they need to design a solution, they have something basically to start with. So today I'm going to talk to you about one of these architectural patterns. I put it into a repository for you. It's in the QR code here. Hopefully, well, you can take the screenshot and so you can have a look at it later if you want to. The pattern is about event-driven, and the talk is about event-driven autoscaling for Kubernetes workloads with KEDA in Prometheus. So what I'm going to show you is a version of a solution for scaling workloads in Kubernetes. What I did is I took a sample application, very easy, that just exposes an endpoint and basically returns just a simple message. This sample application exposes metrics, Prometheus-wise, and one of these is the HTTP requests count. So in order to have an easy reference for my scaling, I'm taking the sum of the HTTP requests as a parameter for me to scaling. This is a very bad solution in a production environment because it's not representative of what I want to measure in order to scaling, and because it's not actually helping me. But it helps me showcase the scaling. So when we talk about scaling, what we do is, of course, we reference to horizontal scaling rather than vertical scaling because well, obviously it has benefits that we all know, and it's more flexible and so on. So what we want to do is to scale our workload, first of all, by incrementing the number of pods. My application and your application should be stateless, so scaling horizontally is actually feasible. After scaling the pods, we will reach in the solution we reach a boundary because the resources, the compute resources that we have, so the substrate of nodes in our data plane is limited, of course. And what we want to happen after that is to support the increasing number of pods is to increase the number of nodes. In order to increase the number of nodes, I am using Carpenter. So hopefully this makes a little bit of sense. What I'm going to walk you through now is this, which is the architecture. And like I said, we are using KEDA. So I'll spend a few words on KEDA to explain what it is, in case some of you don't know. KEDA is Kubernetes event-driven autoscaler. So what it does is basically through what it calls scalers, so sources, it takes, it plugs some information from wherever you want, basically. It has different, again, scalers which can take information from Prometheus, like in our case, or from external sources, like it could be, I don't know, for example, AWS SQS, or other forms of queues, RabbitMQ, for example, or databases as well. So it's very flexible because it cannot leverage only what is inside Kubernetes, but it also can leverage what is outside Kubernetes. And in a cloud environment is actually helpful. So I said that it uses scalers to source the information and the metrics, basically, because we need the metrics. We are scaling through metrics. And it uses scaled objects to represent, which are custom resources. These scaled objects represent what metrics we want to use. It represents the scalars, so the sources of information, and also the KEDA, once it looks at a scaled object resource, and I will show you how it looks like, it takes the scaled object and translates that into a horizontal pod autoscaler resource. It works then in combination with HPA, for short, which will look at the HPA resource and actually act as usual. So looking at the metrics that are reflected into the HPA will scale up and down our pods. KEDA has a very useful feature, which is it can scale down to 0. This is not something that is supported by HPA, but KEDA can easily support that. This is because KEDA can source information from outside the pods themselves, while HPA typically refers to metrics related to the pod. So if you scale your workload down to 0, you don't have a matrix anymore. Okay, in a nutshell, this is what we are doing in our solution. I will expand a little bit and explain these concepts in a little bit more articulated way. So I said that KEDA uses HPA and specifically through a scaled object. So the scaled object looks like this. This is a definition. You can see that you can use different triggers. So we can have like a more traditional trigger, which is CPU based. We can have a RabbitMQ, like represented in here, and the Prometheus trigger, which is the one that we are using in this specific solution. And then this scaled object resource is taken by KEDA and translated into an HPA horizontal pod autoscaler resource. And you can see also in here the different triggers. Of course, this is a little bit more of a complex version of what we are using, but typically you can just use one and therefore have like the Prometheus trigger here, which is the one that we are using, and you will have only this, basically this piece of YAML and manifest in the horizontal pod autoscaler resource. One little note is that you can see here on the left that the scaled object can actually, like I said, KEDA can scale down to 0 pods, and in fact you can have a minimum replica count of 0, which is anyway mapped to a minimum to 1 for HPA. But in any case, behind the scenes, if KEDA sees that this is a 0 minimum, it will use the scale API provided by Kubernetes that is used to scale resources, scalable resources, and it will change the number of the pods down to 0. So this is what we have exactly. So the previous 2 snippets are general. This is what we have in our pattern. And in fact, you can see, that we have a query that sums up all the requests that pods receive. Note that it is taking actually all the requests and summing them. So all requests by each pod. So imagine that if we are, like we are, scaling our pods, it will take all the metrics reported by the active pods and sum them all up. Threshold means 2 because it means that the average requests that we want as a maximum for every pod is 2. So if we go beyond that, the scaling event will start. And this is what we will see in a minute. I planned a small demo, but in any case, if we don't finish, you can finish that by walking through the repo where there is a README file. So this is the translation. Like I was saying, this is the HPA that is produced after looking at the scaled object by KEDA. How the scaling works is that the desired, this is on the top right here, you can see that this is the actual algorithm that HPA is using for scaling, and the calculation is basically the replicas, taken the current number of replicas, multiplied by the relationship between the current metric and the desired metric. In our case, what happens is that if I call the API exposed by our workload, the number of requests will increase, and therefore the reported metrics by all the pods will increase as well, because it's a sum. It's just a sum. It's not an average. It's not a rate. It's a sum. So it will go always up. It's a counter. So and therefore our relationship between the current metric value and the desired that we put, desired in our case is 2. So when we request, we hit the endpoint, every time it will increase. And therefore, the relationship between these two values will increase always. And therefore, the current replicas, which is taken at any time, will need to be increased. So this is why it's actually very bad, because no matter what you do, the metric will go up, and so the number of pods. But of course, we have a max replicas, like you can see here, which is 10. So once it reaches the 10, it will end the scaling up. This is more or less what's happening. We have inside the cluster, we have a Prometheus stack that is implementing deploying the Prometheus server. We have also Grafana deployed, and this is where we are taking our metrics. So KEDA is taking the metrics from there. The metrics are pushed into Prometheus or scrubbed by Prometheus from this deployment, which is the sample application. So KEDA, what it does, it's basically registering an external as an adapter, as a provider, as a proxy of metrics through the aggregation layer in the Kubernetes control plane. The aggregation layer expands the Kubernetes API with additional APIs, and KEDA, in this case, is providing the external metrics. Okay, so just a couple of words on what we are using as capacity autoscaling, because like I said, when we scale out the number of pods, we need capacity. When we start, especially in this pattern, we have just a very small number of pods, nodes. And when we increase the number of pods, like I said, a lot of pods will be in pending state because they don't fit in the current capacity. So our element, our add-on that helps us scale the capacity and the nodes, I'm using Carpenter. Oh, by the way, all this solution is deployed on Amazon EKS, but you can take the same solution and apply that to any other Kubernetes distribution, because EKS is upstream conformant. Carpenter, in the case of EKS, specifically the auto mode version, is included into the auto mode feature of EKS. But again, Carpenter you can deploy Carpenter by yourself. Carpenter, very quickly, is a cluster autoscaler that has a number of advantages compared to, for example, the more traditional cluster autoscaler. It basically helps us avoiding using node groups, and instead it talks directly to the, in the case of AWS, to the EC2 Fleet API. So it can actually request single instances based on node group and node pools, custom resources that we can define to actually guide Carpenter in how to instantiate nodes. Carpenter has a number of other advantages. Between them, it helps you with cost management because it keeps looking at the allocated nodes and the utilization and the cost associated. And if they are not optimally used, it can disrupt these nodes, so remove some nodes, replace with larger or small instances, and therefore it helps you basically keeping track of your costs. The way it works is that when there are pods that are in pending state, it understands that there are some capacity problems, and therefore that triggers the creation of what are called node claims within Carpenter world. Node claims just represent the life cycle of a request for a new node. So whenever Carpenter sees pods that are in pending state, it requests new nodes through this node claim custom resource. OK. So let me now go through this. So I set up the, hopefully, can you see? Is it OK? OK, good. So I already set up everything, OK? Now, what we have is basically this number of nodes. So we have 3 nodes, OK? And what I'm going to show you now is the current value of the metric that I'm basically querying through the Kubernetes API. Like I said, we expanded the Kubernetes API to expose external metrics. In our case, we have a value 0 here, so we don't have any calls made yet to our workload. And therefore, the total number of requests reported is 0. I'm going to port forward a few, the application, endpoint, and Grafana, so that we can explore on Grafana what's happening, and also we can call the API exposed from the application. And this is just a test to show you that, for example, hello from my example application. So I just hit the endpoint, and I triggered a reply. I'm, again, pulling the information. So now the reported metric into Prometheus, and then from Prometheus by KEDA reported into the Kubernetes API, the external metrics is now value 1, like you can see. Now, what I'm going to do is I'm going to create 30 requests. I'm going to do it with 30 requests because I want to because I will have a maximum of 10 pods. 30 requests divided by 10 pods maximum is 3 requests per pod. 3 is above the threshold 2 that we put. And therefore, the scale will go on. OK, so now I'll show you that actually. We have a 31 value, which is the one before, plus the 30 that we just did. And this is the number of the pods. You can see that now we have a higher number of pods. It will be 10. Now it's not. 1, 2, 3, 4. Okay, it's increasing. You see that we have running here, the top one, from 4 hours, and the other ones, we just triggered them. Okay, you can see that now they are all starting up. If you remember, we had the 3 nodes, and now Carpenter just scaled from 3 nodes into another 3. So 3 plus 3 is 6. We can also see how Carpenter did it through the node claim. And these are basically all the node claims which represented the requests of new nodes into the cluster and to the EC2 Fleet API. You can see that they are basically new, 42 seconds, 72, and so on, compared to the other 3, which are at the bottom, because they are older nodes. I think I ran out of time, but I got to the end. Thank you very much. And, well, by the way, if you can, I always like to improve. So very small survey. It's just 2 ticks, 2 ratings, and an optional text field. Up to you. Thank you very much.
Big thank you, Riccardo. We do have time for another question or two, if anybody has something that you want to ask. Going once?
Hey, question regarding the scalability and the performance. You mentioned that you can scale down to 0, but what's the trade-off in terms of latency if you want to scale back from 0?
Well, that depends on how frequently KEDA looks at the state. On how frequently the metrics are refreshed from, for example, of course, they must be external to the pod. You cannot take the metrics from a pod because you have no pods, right? But in terms of pod scaling, that's pretty fast. What you need to pay attention to is if you don't have nodes, if you need to scale the nodes. In that case, also, Carpenter needs to kick in. That's also fast, but of course, because you need to instantiate a new node, that might be slower.
Was there another question back there? All the way up front over here. Put it back up.
Can you scale other resources besides just native Kubernetes things like deployment? So let's say a custom resource that has a number of replicas, like, for example, a database. If there's a replicas line.
I'm sorry,
yeah.
I didn't get that.
Yeah. Can you scale other objects other than like a deployment to scale to multiple pods? Like, can you scale a custom resource like a database to multiple replicas, or can you target like a custom resource for that?
I must be honest, I've always scaled the deployments and the pods. So I'm not sure if KEDA can help you with the scaling. Well, I'm assuming that if you are deploying a database within Kubernetes because it will be running as pods, I'm assuming that you can still be scaling a database if it is running as pods.
All right, last question.
Yeah, correct. They are completely independent. So, and the way it works is by separation of concerns. KEDA objective goal is to scale the workload. Carpenter is scaling the nodes. And the way Carpenter understands if there is the need for capacity is by looking at are there any pending pods? And then it's not Carpenter that is scheduling. So Carpenter is not moving stuff. It will be the scheduler, the Kubernetes scheduler, that when there is capacity, it will place the pods, the pending pods, and put them into the nodes.
All right. Thanks so much. Give them another round of applause.
Thank you.